Hi, this is Wes Simpson, founder of LearnIPVideo.com, and I'm here today for the NAB New York presentation. My guest is Wim Vermost, and he is going to be providing a discussion that I think is very important right now. We have to be talking about why NMOS, the control layer of IP video, is so important. And this presentation will be aired during the AIMS IP Showcase, Alliance for IP Media Solutions. Wim, why don't you say hi and tell us what you do?
Hi, Wes. My name is Wim, so thank you for introducing me. So I'm based in Belgium as we speak. I work for the Belgian public broadcaster, and I work as a design and engineering manager at the operations department. So the nice thing about this job is to bring in new developments into the process we all know of live television, and that's why I love my job at the moment very much.
And you guys have been doing some fairly extensive IP upgrades and renovations. Is that right?
We've been one of the first doing a proof of concept called the VRT, and it was together with EBU, a proof of concept with 2022-6 at the time.
Mm-hmm.
And now we're learning to move to 2110 on the site as well. And we're trying to push it forward into a purely software-based studio, which is a nice effort.
Well, that's nice. And you've also been involved heavily in the EBU, the European Broadcasting Union, as well.
Well, I was working there for, let's say, the past 4 years.
Mm-hmm.
It was a hell of a time. I enjoyed it very much. And this is the moment I really gotten into this industry a little bit better.
Well, that's great. That's great. So let's talk about IP-based media systems. I mean, one of the big advantages of them is that they're so flexible, but one of the drawbacks of them is that they're so flexible. You have so many choices, so many different, ways of communicating, getting signals from one place to another. Um, one of the concerns I think a lot of people have is that with all these different media flows all flowing over a common network, is that it could be a headache to control those things properly, to make sure that you know that the signal that you need to get from camera A to play out B is going to get there when it has to get there, and nothing else is going to interfere with it. So that's really the role of control, right?
Mm-hmm. Yeah, that might be one of the pitfalls that a lot of people don't think of at first sight, because they think, oh, it's probably replacing SDI and plugging another cable. But as you wonderfully said, it gives you a lot of flexibility because you can have multiple video signals over one cable. And then the next question would be, well, how to control this, how to pick the right video signal from this cable. Or if you connect, well, at home, if you're just connecting a PC to your network, well, in the early days, you needed to type in an IP address and to get all those things configured. Well, this is something you won't like to do when you plug in a camera and you plug in a monitor. If you plug it, what happens? Well, nothing. So you need to control it in a bit of a serious way in order to make something really happen there. So this is why a control plane, as I would say, is very important in IP-based systems,
Mm-hmm.
because it abstracts the data from really the control, and this is where those things are nice and handy.
Yeah, that makes a lot of sense. So let's talk about how control is done in the IP world. One of the things that I think a lot of people were used to is having, cables running around with SDI. You could put a label on the cable, you would sort of know what it is. Then you had these routers and control, push button control panels, and all those things where it was fairly discrete and autonomous. It took human operations to change the way that signals went around and things like that. So how are we evolving beyond that, and how do we make the transition from the way things were done before?
This is actually an interesting story. When I really started at VRT years ago, there was still analog audio.
Mm.
And one of my colleagues as a support engineer, he was running around with a headset with those two pins. And he said, listening to the audio path. So he was tuning in with his two pins to listen to it. I was really amazed, right?
Uh-huh.
I didn't realize you could just, the signal was strong enough to power your headset. And then we went from PAL video to SDI. And then the thing I did was, okay, I pull the cable, I plug it onto your monitor, and you can see. Wonderful.
Mm-hmm.
Now, moving to IP, we suddenly realized, well, that's not possible anymore. First, you need those IP addresses and that sort of things. And a lot of comments to type in because you needed to join streams and that sort of stuff. And then I realized we're not the first industry to go to IP.
Mm-hmm.
Imagine the telephony system from years ago.
Oh yeah.
They did a change like that as well. They moved from analog to digital, and then they had TDM or some other mechanism to work on, and now they're fully on IP-based systems. But maybe the best comparison is if you remember that good old picture with those ladies on the switching board.
Oh, okay.
And this is actually the state of SDI. So this is actually how it works right now. If you have just a 2110 system and it uses IP, it's a little bit like this. There's the telephone without the dials, and there are ladies doing the switching.
Mm-hmm.
Now, back in the days of the telephony, well, this is not the best system, right? Well, maybe I should start with security. Do you
Sure.
trust those ladies that they're not listening in to any of your conversations?
That's not always a guaranteed thing.
That's probably not a guarantee. But making and breaking the connection, that was of course manual labor.
Mm-hmm.
As it is right now in a studio, you need to push your matrix buttons to make or break your connection. And since we're talking about scale, this does not really scale very well. The other issue with this is, how do you track the billing?
Oh yeah.
Those ladies don't have notes. They're not just calculating, oh, this guy, he took 30 seconds to make his call. No, you're paying actually to the thing that you're paying is the ability to be switched. Now, of course, in the modern telephony system, you pay by the amount of seconds you're using the network and that sort of things. So it did change. And of course, those ladies couldn't take all the work on their hands. So they needed to find something innovative to scale up everything. And the way to scale it up was pretty simple. It's automation. So there's a layer on top of the data plane, or the voice, I would say, in this case. And well, that's what you see right here. And on the left-hand side, of course, the dial. And at this moment, I'm sure there are people amongst us that don't recognize the dial like this, or don't know how to operate it. Yeah, I do recognize it, I must admit. Now yeah. Something completely else. Imagine when they built a telephony central like this, or an exchange, and it were the Alcatel, Bells, and Siemens, and whatever manufacturers you had at that time. And if they didn't agree on a common protocol to interconnect those exchanges, how would it be possible to call, let's say, from Belgium to New York?
Mm-hmm.
It's probably not. So it's very important in telephony, and they understood not right from the beginning, but they understood pretty soon that in order to sell more of those telephony exchanges all over the world, they needed to talk a similar protocol to control the telephony signal from A to B. Mm-hmm. So that's what I took away from the telephony example.
Yeah, I think that makes a lot of sense. I mean, it really was a progression. One of the things that you have to deal with in real telephone networks, well, up until recently, is sort of that concern has gone away to a certain extent, is you had to worry about making sure that your long haul links were not going to be oversubscribed, that you didn't have too many signals flowing down them at any one time, and also make sure that you had the ability to connect any input to any output. So we're kind of moving into that same phase within the IP video world as these systems get truly large. I mean, I've heard people talking about systems with hundreds of thousands of media flows on them. We've got to be careful to manage all those correctly, right?
Yeah, you wouldn't be willing to do this manually. Then that's really for sure. If you start building systems like this that can scale to a really enormous size, you need to have this control layer on top. and for sure an automatable control layer.
Yeah, no more big Excel spreadsheets with IP addresses, right?
Oh, God forbid. No, please don't.
So let's talk a little bit about some of the technologies that are starting, that are more than starting, the technologies that are really, you know, arriving in time to make these automation processes more straightforward and and automatic, like we were talking about.
Well, where you could make the analogy towards video now, the data plane or the voice in the telephony example, the data plane would be 702110,
Mm-hmm.
right? And that's the video that can be carried over a network. Now, on top of this, and actually, I think the first specification was brought out by AMWA even before 2110 was released officially. That's the discovery and registration mechanism. Now, that's maybe already a little bit like, what are you, what are you saying?
Mm-hmm.
But of course, if you start to think about it, our video world is a little bit more complex than telephony. We don't only have telephones, we have cameras, we do have video switchers, we do have screens, we do have microphones and all different type of things. And they need to be on the network and they need to say, oh, maybe I'm a cameraman and or I'm a camera and I can send out an HD stream and I can send out one. I can receive a return feed. It could be SD and all the sort of things that needs to be told somewhere in a register. That's an important piece of that control layer. Now, when the moment you know what's on the network, you need to be able to connect it, right?
Mm-hmm.
Not because you just plug a camera and a screen that it works, or if it's discovered to be a screen and a network. No, at some point you need to be able to say, please, dear camera A, your output needs to be connected to the input of maybe screen B. And all those different pieces of the architecture have been laid out in AMWA interface specifications. And that's a very important piece of work that has been done, because this is actually, it's open, it's all on GitHub, and it gives you an interoperable control layer over all the possible 2110 implementations.
Yeah, that makes a lot of sense. So given these, these functions, how do you go about building a network? How do you make something that's going to do what needs to be done in a modern broadcast network? What are the pieces that you really need to have?
Yeah, you need to have some kit to start
Sure.
with. An IP network. Now, once you have an IP network, you need to be sure that you have a synchronization system.
Mm-hmm.
If we compare it to our current system, we do have Blackburst or a tree-level sync or whatever you have. So something to synchronize all the things. In our new IP world, this is PTP.
Mm-hmm.
Or maybe some of you have heard about IEEE 1588. Well, it's probably much nicer to talk about PTP instead of these abbreviations.
Sure.
We need to have a clock, a good IP network. There needs to be some kit to be connected to the IP network. And then we can start to talk about controlling the things together a little bit. This is where you start hearing things like registry and discovery services, connection management, and that sort of things. Maybe I'll pull up a slide.
Sure.
And to be honest, this is a slide that probably has been forgotten, but I updated it in time a little bit. My only update was to move the red line in the year.
Okay.
But actually, oh, maybe I should explain it a little bit. So at the bottom layer, you had the SDI layer, but this roadmap was talking about IP. So
the bottom layer, the blue down at the bottom, is the SDI, right? Okay.
There's a black called 0.SDI.
Okay.
Of course, we didn't describe anything in it. It's not because we didn't describe anything in it that SDI is dead. No, it was mentioned on IBCs and NABs years ago, but SDI is not dead. But on top of this, smart people discovered, well, if we change SDI and we wrap it into IP, then we already have our IP network. And this is what we have with 2022-6.
Mm-hmm.
But of course, in a studio, you don't use all of the signal all the time, right?
Right.
There's the embedded audio, the ancillary data, that sort of things. And if we're using an IP network, this is probably too much of data going on. You can squeeze down the bit rate if you just use the elementary flows.
Mm-hmm.
And
So
this
the
is
video and the audio and the ancillary data all separate. Yeah.
And I think smart people at VSF, they made something called TR03.
Mm-hmm.
And that was actually the start of elementary flows, and that actually led into 2110. And this is why I say the elementary flows layer, the red zone you see here on the map, that's the data plane.
Mm-hmm.
And within the data plane, you find all the documents of the SMPTE standards. It's not just one document; it's a bunch of documents. It's a suite,
Mm-hmm.
as they say. And this is what I call the data plane. Now on top, there's the number 3, network and resource management. It was called at that time, and this is what we say the control plane. And this is where you find the things like there should be registration and discovery or connection management, the ability to make connections between senders and receivers. Then there's a weird duck, but I'll come back to this. Of course, when you have a studio, you have a red light on a camera when you're on air. So the event and tally, that's an easy one. There's a special one called audio channel mapping. And actually, at some point, they discovered, well, if we have a stream and it has 8 channels of audio in it, and you connect your IP-based speaker to the network, how does the speaker know what channel to pick? So there's an ISO 8 that describes how to deal with this type of situation. So it feels like something dumb, but actually this solves a really interesting problem.
Mm-hmm.
Really. Now in the middle, and I think you pointed it out, because the similar thing in telephony that happens, you have these tie lines, right?
Mm-hmm.
And not all people that can pick up their phone can phone at the same time because the network resources are limited. Well, for sure in the case of a telephony network. So they thought at AMWA to make something they called the network control. And that's actually an API to control the IP network.
Mm-hmm.
Because at some point you might want to control the network with a software-defined network or a network controller that enables you to ask the question to the network, is there still room enough to set up a new flow? If there's no room and you set up a flow, it might, well, not happen, right? Or you might disturb other people as well. So this is why they invented AMWA ISO 6. That's a northbound open API,
Mm-hmm.
lot of difficult words. And that can be implemented by brands like Cisco or Arista or whatever. Mm-hmm. Now, I must say, years ago, it took a giant start, but then I think even the drafter or the proponent said, I think it is dead, because networks suddenly became very powerful, etc. But there might be still some interesting need for the network control API here. So don't think yet it is lost or it is gone, mm-hmm. or you don't need it. Just be sure that this is available in your toolbox when you're building something.
Right, right. That makes a lot of sense. So let me ask you. You know, all these different standards. I mean, they're open standards. They're available on GitHub. There's documentation to go with them and things like that. But you know, the media community is not expecting, you know, most end users to download that code and start you know, installing it on their Unix machines. There's an easier path for people to get up and running using these control systems, isn't there?
Yes, thank God.
Yeah, really.
Otherwise, I would have issues myself, I think.
Yeah.
So we do a few master classes with EBU, and we talk about. I think we've talked with over 500 students about this, and some of them come back to me. They say, "Oh, I've compiled this," and I look with these big eyes because I've never compiled any of those things.
Mm-hmm.
Because if you look a little bit nicely on the internet, you find that a lot of people really actually build it, and you can just download a Docker container and spin up a Docker container, and there you have a registry. I think Sony made one publicly available and for free. There's a guy from Mellanox. Well, that's being bought by NVIDIA right now.
Mm-hmm.
He also built a lot of things and makes all the explanation how to do it online. So actually, it's not a big deal to do it even for free and without a lot of hassle.
Mm-hmm. So go ahead.
Yeah, not to worry about. Probably in your I would say plant, you do have somewhere a guy that knows how to set up a mail server or controls the mail server or whatever. If you have a little bit of IT skills, it's good enough to start that type of applications.
That's great. That's great. So tell me about your own experiences with these things. I know you've been, sort of, moving from, between two different organizations and things like that, and involved in some of the pilot things that were going on. What has been your experience with the control layer? Has it been something that's been a real steep challenge, or has it been something that required some careful work with a vendor, but once you got it up and running, it wasn't too big a deal?
Now it's a little bit of another story, I think.
Okay.
Because the specifications, they were out. There's no problem at all. But of course, there were products on the market already. They wanted to push it on the market as soon as possible, and probably all those vendors have been working in their labs with their own control layer.
Mm-hmm.
So this is why completely at the beginning it was difficult to find NMOS with all the specific vendors. But now I think seeing the results of JTNM tested, there are a lot of brands that now come with NMOS control out of the box. So the situation improved a lot. So that's actually very good. And I've seen it's on the AIMS roadmap for a while now. So actually the whole industry is pushing for this. So there's nothing to worry about at all. You just need to be sure, if you're eager to buy a particular piece of kit, that it actually does integrate with the NMOS specifications. But,
well, and that's been made a little bit easier by the JTNM tested catalogs that have been published for over the past couple of years.
Yeah, you can find in those catalogs what type of kit already was tested. Because actually there's a huge test effort that has been done. Of course, the JTNM tested, but I think some colleagues from AMWA and a lot of guys from Sony and BBC even worked on a piece of software in order to do those tests to see that everything is really working according to the specifications. And those results you can find back in the catalog. And that's really promising. If you look at the catalog, you see those all those boxes really, really performing very well. So that's interesting. And well, moving from those, let's say, firefighting upfront, looking into the labs of vendors, now being a customer myself, and looking at the guys in my lab, that they were playing with old kit, well, old from maybe a year ago. And it was horrible, actually horrible. They needed to configure bits and pieces, go very deep into the interface. And now recently we got a new piece of kit, and I said to the guys, well, it's new, it's brand new, and I just need to figure out, the only thing I need to do is to give feedback to the vendor to say how it really performed. So I was eager to see how long they were going to fiddle around before getting it up and running, right? Now I was completely amazed, because within 5 minutes,
wow,
the thing was up and running and really operating. It was a piece of kit to generate streams. And
wow.
it was an easy click on the button. It's like, oh, we're running 50 Hertz, click. Oh, it's PTP locked, great. It was really amazing.
That's really good news to hear. So VRT was truly a pioneer in these IP media systems and solutions and things like that. And the old saying, sometimes pioneers get arrows in the back. Do you, is the system that you put up still up and running? Is it doing what it needs to do? Is it
Now I'll start smiling a little bit, because
okay?
the thing we wanted to do is to be very knowledgeable, because we were going to build a new building in Brussels.
Okay.
Now, due to the price being, well, whatever, maybe the double of what we had expected and calculated, we were not going to build that building. So normally at this moment, we would have been seated in a new building.
Oh,
so
wow.
It will be postponed to 2026.
Wow.
So that's quite a while. So if you think about it, we were spearheaded.
Right.
Then we were pausing a little bit before the new building, but now there's no new building. So now we can take the benefit to look really from scratch again and try to move whatever we have in pure software-based studios. I think this is probably the next step that we'll be heading to. But this won't be for the next 4 years. I hope it will be soon, but let's see where we get. But actually building a facility now with 2110 and NMOS, that shouldn't be your biggest fear at all.
Mm-hmm, mm-hmm. So let me ask you, the pure software, what problems or what issues do we need to solve? What are the things that you're going to be looking at for the next year or two to try to make sure that those things are going to support all the needs that you have as a broadcaster?
Well, the pure software sounds a little bit strange.
Mm-hmm.
There are two strategies here. So do we want to have it all on premise? Or do we want to build it in the cloud? Now, building it in the cloud, that's another type of difficulty, I would say. But building it on-prem with all software, the benefits you could get seems amazing. But it's not only the backend, because the thing we were trying to innovate on back in the days with 2022 was actually the process. How many people do we need to have in our gallery to make a good program?
Mm-hmm.
And now with our current SDI facilities, well, there are an amount of chairs, because you do have seats with a vision mixer, the graphics artist, the shader, and so forth. But now for some programs, you don't need to have so many people.
Mm-hmm.
So we're going to look into how flexible we can make those positions. Can it be maybe a vision mixer and a shader in one, or can it do multiple things? Or is it the director that does the cutting? Because cutting can be made as an abstraction layer from a real vision mixer. So that's quite an interesting journey that we're going to take. But all of this, of course, cannot happen if we don't have the base layer like we do here, like we do have in front of us right now. That's the data plane and the control plane. All the rest is just happening on top.
Mm-hmm. Mm-hmm. So it sounds like you've got a lot of experience with the IP. Is there anything that you would say that people should try to master before they dive into something like this? Is there anything that that any advice you want to give to people that are moving in this direction?
There's even another question that typically gets asked, but let's try to answer this one first.
Okay.
And maybe it gets us automatically to the second one.
Sure.
So usually our answer is like, try to build something small.
Uh-huh.
If you do have a spare studio somewhere, or maybe a corner with a desk, start play with a small lab and just a few senders, few receivers, a switch. Make it as simple as possible and try to grasp all the concepts. Now, once you're doing this, you easily get into the idea like, I'm a wonderful broadcast engineer. I know the IP pattern and that sort of things, but what about IP?
Mm-hmm.
So suddenly you start to drag in your IT engineer that knows a little bit about the IP network. And this is where the magic happens, or should happen.
Right.
Now, everybody that comes across this type of technology should be eager to learn. it should not be the best one or the guy that can solve your mathematical equation,
Right.
so to speak, but they should be eager to find out how it really works and what are the tweaks you can do or how it works. Otherwise, you'll run into trouble because at some point you need your IT engineer. You need a guy with broadcast know-how because they've been in touch with Blackbird. They know why you need synchronization, right?
Mm-hmm.
And so on. So you need a few profiles in a working group like this.
Yeah, I think your advice about starting small, prototyping something, really, shaking the bugs out makes a lot of sense. That's really good advice. So do you think that the powers that be, the folks, up in the executive suite, if you will, of your organization, are happy with the move to IP? Do you think they view it as a good business decision?
Well, I think it's even not a business decision, to be honest. It's maybe just an economical fact. So a while ago, I was looking at some figures because somebody told the actual story to me, and I thought, what is this guy saying? And actually, if you look at it and you think about the broadcast business as we are the broadcast business, there's a certain amount of revenue being spent in the broadcast business.
Sure.
If you compare this to the broader IT industry, well, we're just merely 1% of the broader IT industry. And if you think about this twice, well, it's fairly easy to see that there's a lot more development in the IT world. So speed of network switches and that sort of things, it goes much faster than in our world.
Mm-hmm.
So this is why you can actually see that it is a given. Everything is pushed into the direction of IP in order to get the scale of economy. So is it a technology decision at first? No, I think it's an economical decision because everything is really moving in a similar direction. At some point, probably they thought telephony will never go to IP because it's not possible. But hey, here we go.
Yep. No, I mean, yeah. I don't think Zoom would work too well over an ISDN network. So, yeah.
I think we can even not try anymore in Belgium.
Yeah, I hear you. I don't. Yeah, I don't think you're able to buy ISDN anymore. Well, very good. So Wim, thank you very much for your time. This is really interesting. I think you bring a nice perspective, having, worked in the standards, worked in the real world of a broadcaster, and I really like your analogy. So I think that was very appropriate.
Oh, thank you, Wes, and kind of you to invite.
Yeah, well, thank you, and we'll look forward to seeing you again when either virtually or in person, and maybe at some point in the future. That would be great.
Well, let's hope we can all meet again live.
Very good. Thank you.
Thank you, Wes. Good evening.